Hey Algebra 1, here are the notes for 9.4, day 1. So our goal, we know how to factor quadratics with a leading coefficient of 1. So that's what this says. What happens when the leading coefficient is not 1? So instead of having something that looks like x squared, yada, 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 now instead we'll have something that looks like this, 4x squared with all the following. Well, it's very similar. But let's first start by foiling something that will show us some of these examples. If I FOIL this, I'm going to get 12a squared positive 4a minus 3a minus 1. And when I FOIL, you'll notice I have 4 distinct terms. When I simplify it down, I have 3 distinct terms. So I go from 4 down to 3. Now, one of the cool things is we are going to learn how to go from 3 back up to 4. But there's a lot of ways to get a 4 and a 3, to get 1 with numbers that aren't 4 and 3. 5 and 6, 7, 8. I could go on for a while. So let's now learn how to factor these and how to break it up into these middle terms so that we can unfoil, or how to factor these. So step 1, I need to set it equal to 0 the same way that I have been doing up to this point. I need to make sure that all of my terms are on one side of my equation. So set equal to 0 and combine like terms. So make sure it's in standard form. Standard form. Once I have done this, I'm going to create an X puzzle. Create X puzzle. Now, why am I going to use this X puzzle? Well, before we could just see what multiplied to C and added to B, but that's when there was a 1 in front. Instead, now we have to see what multiplies to A and C, but adds to B. So we have to take that A into account. We do that by multiplying A times C on the top. So negative 12 on the top and a positive 1 on the bottom. Now our method pretty much stays the same. We find the factors of 12 and we see which of those pairs adds to 1 or could be used to get to 1. Notice a 3 and a 4 could get to 1 as long as we made one of them negative. Coincidentally, we notice one of them has to be negative because the only way to get to a negative 12 by multiplication is by multiplying a negative times a positive. Now, don't get excited and think that these are your factors. What we're actually doing is going from 3 into 4. So why do we want 4 terms instead of 3? Well, let's rewrite this and find out. If I rewrite this as 12a squared minus 3a plus 4a minus 1, what I can do is I can use factoring by grouping. Factor by grouping in order to get these terms that we know. So how do we do that? Well, we talked a little bit about factoring binomials the other day. We have to see what they have in common and pull it out front. So in this case, the GCF of these two terms is 3a. What's left over is going to be a 4a minus 1. In this case, all these have in common for a GCF. When they have no other numbers in common, they have a positive 1. So what's left over is a 4a minus 1. And what this allows us to do is now what do the first term and the second term have in common? They have a 4a minus 1. When I factor that out of the first term, I'm left with 3a. When I factor it out of the second term, I'm left with a plus 1. Now, oddly enough, if we go back up to this example, you'll notice that our 4a minus 1 matches our first term, and our 3a plus 1 matches our second term. So, by using this X puzzle and factoring by grouping, we can factor things that have a leading coefficient that is not 1. Now your step 4 in this case, there's quite a few different ways to write the steps. I always like to go back and check and FOIL it back out if possible. But you could also just say that your 4th step, if you don't want to check, write as a product. I feel like people sometimes forget this. They like to leave it at this step. This is not a complete factor. We need to write it as the product of these parentheses. So let's see a few more examples of this. If I do 3x squared plus 2x minus 8, it's already set equal to 0, so I can skip right to step 2 where I create my x puzzle. I'm going to say a times c on the top, on the bottom. A times c in this case is 3 times negative 8, or negative 24. B is just a positive 2. I'm going to quick write out my factors of 24 as 1 and 24, 2 and 12, 3 and 8, 4 and 6. Now somebody asked me the other day, why didn't we use the x puzzle with the leading coefficient 1? Well, we could have, but it would have been a lot more work to then rewrite it and factor by grouping. So we only want to use the x puzzle when we have a non-1 leading coefficient. All right, let's get back to it. Which of these pairs can be used to get to the number 2? Well, I notice a 4 and a 6 can do it. And since I know one of them has to be negative to multiply to a negative number, I need to make one of them negative to a positive 2. If I make the 4 negative, I get negative 4 plus 6. That is a positive 2. If I flipped those signs, I'd get a negative 2, and that would not be right. So I have to be very careful about which one I put the negative on. Now I'm going to come down here, and I'm going to rewrite this. I'm going to break 3 terms into 4 just by rewriting the middle term. Remember, we only want to change b. We don't want to change a or c. So 3x squared comes down. My little trick is I like to see with this first term, does it have more in common with 4 or more in common with 6? I personally think it has more in common with 6, so I write plus 6x. I then write minus 4x minus 8. Notice the c comes down. All I changed was the b and how I wrote that. All right, now we're going to factor by grouping. These two have a 3x. We're left with an x plus 2. These two have a negative 4, and I'm left with an x plus 2. How do I know I did my factoring by grouping correctly? Well, if I did, I should see that these two terms are the same. If they're not, I can't pull them out to the front because they would be different. But since they are the same, I'm going to pull that out. What's left in the first term is just a 3x. What's left in the second term is just a negative 4. And I have now factored this into a product. All right, let's do another one. Quick x puzzle. A times c on the top is negative 12. B on the bottom is negative 4. Factors of 12 are 1, 12, 2, 6, 3, 4. A 2 and a 6 will get me there. If I want a negative 4, I need to make the bigger number negative and the smaller number positive. Rewrite with the a come down. 4 has just as much in common with both of those, so I'm just going to put the 2 out in front. Plus 2x minus 6x. The c comes down. I know this is getting kind of hard to see. It's a little messy. Factor by grouping. The first two have a 2x in common. I'm left with an x plus, or 2x plus 1. The second two have a negative 3 in common. I'm left with a 2x plus 1. Bring the 2x plus 1 out to the front. I'm left with 2x minus 3. All right, I'm going to leave that final one for you to attempt. And then we're going to look at these last two. So before we start these, what do we notice? Well, with this one specifically, I notice that those are all pretty big numbers, and I could use the x puzzle, but I could start by factoring out the GCF and making all those numbers a little smaller. If I notice that they all have a 2 in common, I can factor that out to the front so that I'm left with 2x squared plus 13x minus 24. Now I can do the X puzzle with just the inside information. So then I don't have such big numbers to work with. Negative 48 and 13. When I list out my factors, I see that a 16 and a 3 work. And I can rewrite it as negative 3 and positive 16. Now the 2 just comes along for the ride while we continue our X puzzle the way that we have been up to this point. Positive 16x minus 3x minus 24. And the 2 just keeps hanging out. We factored that out. We can't forget about it. We can't leave it behind. But we don't have to worry about it for right now. All right, 2x gets pulled out. We're left with x plus 8. Pull a 3 out of those second 2 terms, we get x plus 8. Again, the 2 is just coming along for the ride. I'm not going to repeat it for this step. But when I pull the x plus 8 out, and I'm left with 2x minus 3, technically I still have to multiply everything by 2. So the 2 comes down with it. And this is my final answer. Just because we factor it out at the beginning doesn't mean it doesn't have to come along and be part of our answer in the end. All right, one last one. When I factor out a 2 of this one, because I see they all have it in common, I'm left with kind of a conundrum. I'm left with n squared minus 7n plus 9. And after I've looked at this one a little bit, there's not going to be anything that multiplies to 9 but adds to 7. So for the purpose of this homework right now, I want you to write prime. This just means that we can't break it down with any of the methods that we currently have. So this is going to be a no solution yet problem. However, once we've studied a little bit more and we've seen some other great examples of how to solve these, we will eventually be able to come back and figure out how to complete this one. Just not today. Keeping you in the loop, but also keeping you in the dark. So come on back for more great math. Let me know if you have any questions.